Hey, what's going on, guys? Let's do this problem right here. This question is asking find the radius and intervals of convergence. So the first thing we have to do is we have to take the ratio test. Ratio test is going to be limit n approaches infinity and we take an plus 1 over an, right? And an plus 1 is basically wherever we have n, we just add 1 to that. And when I take limit n approaches infinity, and if this one comes in absolute value, this negative one will not appear because it's going to be plus 1, right? So plus 1 power n is going to be just 1, so we can eliminate this one and write this one only. So this is going to be x plus 2 power n. So here we have to add 1 more to that, so that's going to be x plus 2 power n plus 1, and in the denominator we are going to have n plus 2, and then we have ln n plus 1, so that's going to become ln n plus 2, and then we have to divide this one by this one. It's same as multiplying by the reciprocal of this one, so that is going to be n plus 1 times ln n plus 1 over x plus 2 power n, right? X plus 2 power n. From this one we can cancel some values, like this one x plus 2 power n we can cancel with this one, and here we have x plus 2 power 1 is remaining, and then that's the only thing we can cancel. Now let's arrange this one according to like terms together, like limit n approaches infinity x plus 2 over 1, and we have n plus 1 over n plus 2, n plus 1 over n plus 2, and then we have ln n plus 1 over ln n plus 2, right? Now this one we can't do anything because we can take this one outside also, because we are only dealing with n, so we don't need this one. This one we know the limit is going to be just 1 because we have same powers, so the ratio is going to be the limit, so this is going to be 1, limit of this one is going to be 1. And to take the limit of this one, if you notice, this is ln, right? So this is infinity over infinity. Here we have to do the L'Hopital rule. So if we do the L'Hopital rule for this one, limit n approaches infinity, so the derivative of this one is going to be 1 over n plus 1, and then derivative of this one is going to be 1 over n plus 2. So when I divide this one by this one, that's same as multiplying by the reciprocal, so that's going to be n plus 2 over 1, and then we can write this one as limit n approaches infinity n plus 2 over n plus 1. Again we have same powers, so we can take the ratio as our limit, so 1 over 1, that's going to be the limit. Again this is going to be 1, right? So this is 1, this is 1, this x plus 2 is, we can take it front, so the final conclusion is going to be x plus 2 times 1 is going to be less than 1, right? So from this one we can find the endpoints. Endpoints is going to be x plus 2 less than between negative 1 to 1, and then if I move 2 to the other side, that's going to be negative 3, and then we have x, and if I take this 2 to this side, that's going to be 1 minus 2, that's going to be negative 1, right? So this is our endpoints. Now we have to find the intervals of convergence. To find that one, what we do, we check whether this one converges or diverges. That's the one we have to find out. Now to find that one out, what we do, we plug these endpoints in instead of x and see whether that series converges or diverges. Now let's go ahead and do for negative 3 now and see what happens. So let's take x is equal to negative 3. So if I apply x is equal to negative 3, this is going to be sigma, so summation n is equal to 1 to infinity, and then we are going to have negative 1 power n. Here we have negative 3, So negative 3 plus 2 is going to be negative 1, right? So negative 1 power n again. And in the denominator, we are going to have n plus 1 times log n plus 1. Now, negative 1 times negative 1 n, we can combine this one as negative 1 times negative 1 over n, right? So, negative 1 times negative 1, positive 1 power n is going to be just 1. But because 1 power anything is going to be 1, so we can just write 1 here. So, this is going to be n is equal to 1 to infinity and 1 over n plus 1 log n plus 1. You may have already noticed that we have the derivative on the upside. So whenever you see something like this, the first thing we try to do is we try to do the integral test to find out whether this converges or diverges. So in this case, if we take integral of this one, 1 to infinity, 1 over n plus 1 log n plus 1, right? Log n plus 1. So now instead of n, we can write this one as x. X plus 1 log x plus 1, right? Dx. Now if you notice that we can do the Juice substitution. So let's raise some of the parts. Okay, so here we can do the Juice substitution. So Ju, if I pick up Ju as this value x plus 1, Ju as log x plus 1, and then du is going to be 1 over x plus 1 dx, right? Now we can replace 1 over x plus 1 dx with the du, and log over x plus 1 is going to be Ju. So the integral is going to be integral 1 to infinity 1 over Ju. So now let's avoid this one and take 1 over Ju. So 1 over Ju, and then we have 1 over x plus 1 dx. That's going to be du, because 1 over x plus 1 dx is du. So we wrote everything in terms of u, and if you integrate this one, that's going to give you log u plus constant, right? Now we have to see, since this is an improper integral, so when we take the limit of this one, we take limit t approaches infinity, log u plus constant. Now when we take this one, we don't have to write constant anymore, so we have log u. Now we can replace u with log x plus 1, so this is going to be log x plus 1, right? X plus 1, and that is going from 1 to infinity, right? Now let's try to plug these values. So let's see how we can apply this one. So first of all, we can write this, so we can separate this one into two parts, like we have to apply these values, right? So this is going to be log, instead of x we plug infinity, so this is going to be infinity. Actually, before I do that, I have to write in terms of t. So this is going to be t limit t approaches infinity log t plus 1 minus log Maybe I get rid of this one too, right? So minus ln, again we have to put ln t plus 1, right? So here what we are going to do, we are going to substitute infinity and then 1 again, right? So if you substitute infinity for this one, this value is going to be infinity, right? So this value is infinity. You can write 2 right here because 1 plus 1, that's going to be 2. So we can just write ln 2 right here. And it doesn't matter. No matter what you subtract, like whatever you number subtract, it's not going to make any difference because we have infinity right here. If you subtract, it's still going to be infinity. So this is infinity. Since the limit is infinity, we know that this is a divergence series. So since this is divergent, this -3 is going to be in the open bracket. Now let's go ahead and find what happens if we plug -1 to this function. So if we plug -1, this is going to be -1 plus 2. That's going to be plus 1 power n. So that's going to be just 1. And we are going to have -1 power n remaining. So let's go ahead, let's trace everything. We know that this is divergent. That's the most important thing. After we done, we don't need this information anymore. Now let's go ahead and do the next one. Okay, now let's apply this -1. So x is equal to -1, and if you apply this one, we know that this is +1 power n. So this one is going to be just 1, and this is going to remain. So we are going to have sigma n is equal to 1 to infinity -1 power n over n plus 1 times ln n plus 1. So this is an alternating series, right? Because we have -1 power n. So this is an alternating series. To find whether an alternating series convergence or divergence, we do the convergence test. That's the limit has to be, in order to be convergent, the limit of this one has to be 0 and the function has to be decreasing. Now here we only take bn value. Bn values basically when we eliminate this -1, whatever the value left, that's going to be the bn value. So here the bn value is going to be this one. Limit n approaches infinity. This is our bn value, 1 over n plus 1 times ln n plus 1. And we know that if you apply infinity for these n values, this is going to be 1 over infinity, then that's going to be 0. So this limit is 0. So that's passing one of the convergent test condition. Now let's do the second one. Second one, this has to be decreasing. And if you take this function and check 1 over n plus 1 ln n plus 1, you can see that as the n numbers increases, this denominator value become bigger and bigger, right? So as the numbers increases, this value keep decreasing. So this function is decreasing. So this is also passing the next test. So this series is convergent, right? So therefore we had to put this -1 in closed bracket. So this is going to be our intervals of convergence. Now we have to find the radius of convergence. So radius of convergence is actually is going to be the length of this one. That's, you can calculate by simply subtracting final minus initial over 2, and that's going to give us 2 over 2, and that is equal to 1. So this is going to be our radius of convergence, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.